Welcome to this LearnElectrics video about three-phase electricity. In this two-part mini tech tip series, we will answer some of the questions that we are often asked about three-phase and its uses. We will talk about what three-phase is, about three-phase generation, and how the phases are related to each other. In part 2 of this mini series, we will expand these ideas further and look at three-phase usage, how to get single phase from three-phase, and some useful information about three-phase motors. Here is the typical three-phase waveform that everyone recognises. The harmonised cable colours for the phases and neutral are shown here. New installations should be wired with phases L1, L2, L3 coloured brown, black, grey in sequence, with the neutral cable coloured blue, plus the earth of course. The old colours were red, yellow and blue, with neutral coloured black. You will still come across many installations with the old colours, so expect to see both colour schemes in use in your work. In this video we will use the old colour scheme as red, yellow and blue show up much more easily on the screen. We should begin our understanding of three-phase by looking first at single phase. This is our typical single phase waveform. So what will this tell us and how can we label it? On the right hand side we have labelled 3 points, plus 230 volts, minus 230 volts and the 0 point or neutral point. Neutral and earth are the same point electrically back at the transformer, so this will also be at earth potential. The waveform, the voltage, will steadily rise and peak at 230 volts positive above the neutral point, and then move in the negative direction to peak at 230 volts negative below the neutral. We call this 230 volts peak to peak. These values are displayed on our test meters in what is called RMS values. More about this later in this series. One cycle of the waveform begins from the point at which the electricity crosses the 0 point or neutral line in a positive going direction, all the way to a positive peak, back across the neutral in a negative direction to a negative peak, and then back up to the 0 point in a positive direction. Then it starts again. Positive, negative, one cycle. Positive, negative, the next cycle, and another, and so on. In the UK, the public network operates at 50 cycles per second, or 50 Hertz, using the standard naming convention, and you will hear both being used. This is a very simplified explanation of single phase generation. The rotor in this drawing is going to spin at 50 cycles per second. It is made of a powerful magnet with a north and south magnetic pole. It starts here at a central position between two coils on the stator. We use the word rotor for the rotating part and the word stator for the stationary part. As the rotor is central at the moment, the voltage waveform is at its 0 position and no voltage is flowing. The lamp is unlit. As the rotor spins, it will move closer to the coils and the magnetic lines of flux will cut across the coils. This will cause a voltage to be generated in the coils in a positive direction. As this voltage rises, the lamp will begin to light up. The rotor will continue to spin and it will reach a maximum position where the magnetic flux is cutting across the coils with maximum effect. This is the point of maximum voltage in a positive direction, and the lamp burns at its brightest. The rotor will continue to spin, and as the voltage falls, the lamp dims, until the voltage builds up again in the negative direction and the lamp becomes bright again. This process continues, the lamp continually brightening and dimming as the voltage fluctuates. But it is happening so fast that our eyes only see one bright light burning constantly. Let's look at the rotation. And this process will keep repeating itself 50 times a second. We can look at three-phase generation next. Here is our generator, and instead of just a red set of coils, it now has a yellow set and a blue set. On this drawing we have the generator and an electric motor that the generator will supply power to. Also shown is a simple voltage indicator representing the voltage on each phase. The voltage will rise and fall, positive and negative on each phase, as the lines of magnetic flux in the rotor cut through the coils on each phase in turn. What is going to happen? Start with the rotor spinning and follow the yellow striped arrow. The spinning rotor will cause the lines of flux to cut through the coils. A voltage will be generated on each phase in turn, and this will rise and fall. As the voltage changes on each phase, the electric motor will follow this voltage and begin to rotate at just about the same frequency. Let's see this happening now. And you can see the rotor spinning inside the generator, and the motor is spinning in synchronism with the rotor. What does this do to our waveforms? How are they built up? Beginning with the red phase, we can see that one cycle of voltage generation is a full 360 degrees of rotation. The voltage fluctuates smoothly about the neutral or midpoint in this particular waveform that is known as a sine wave. The shape of the sine wave shows by how much the lines of flux are cutting across the coils, and hence the size of the voltage generated. The yellow phase is exactly the same, except that it is shifted by 120 degrees from the red. There are 360 degrees in a circle. 360 degrees divided by 3 phases is 120 degrees. And the blue phase is, as expected, just the same. This time it is shifted by another 120 degrees, making a total shift of 240 degrees from the red. Those 3 phases laid on top of each other will look like this, our typical waveform. We can see the waveforms being built up here, beginning at the point that the red cycle crosses the 0 point. And as we expose more of this waveform, you can see there are a couple of additional interesting observations that we can make on this 3-phase waveform, and they are important to understand. The first is that there will never be a time when all 3 phases are in the same half. We can never have all 3 phases positive or all 3 negative. At this point here, the blue is positive, the yellow is negative, and the red is at 0. Look a little further along and we have the red as negative with the blue and yellow both positive. And here the yellow is positive and the red and blue are both negative. Another fact with 3-phase: the numerical sum of the 3 voltages at any point will always be 0. Look at this point here. The red phase is at a maximum and level with the line marked 1. This is the mathematical sign value of 1. The yellow and blue are both level with minus 0.5, 1, minus 0.5, and minus another 0.5 is 0. Move the waveform along a little and we have red and yellow both at plus 0.5 and blue is at minus 1. Add these together, minus 1 plus 0.5 plus 0.5 is 0 again. Choosing another point, we have red at 0, yellow is at plus 0.86, trust me on that number, and blue is at minus 0.86. Take one from the other and we have 0 again. And we will use this information in part 2 of this mini Tech Tips series. In part 2, we will take our knowledge further and look at, amongst other things, star delta transformers. How does the electricity get from the overhead pylons into your consumer unit? Why 230 plus 230 equals 400? An interesting subject that is easily explained. And how do we get a single phase supply from a 3-phase distribution board? Plus, why phase direction matters and about making electric motors go backwards. Just how do we change a motor's direction of rotation and why does it work? Well, that's it for part 1. We hope that you enjoyed it and that you have added more knowledge to your mental toolbox. Part 2 of this 2-part series is in the following video. Please click on subscribe below to have access to all of our videos, and please press the notify button to be sure of not missing the second part of this video. Subscribing also helps us too, and we really do appreciate this. Typing in LearnElectrics, all one word, into the YouTube search bar will also give you access to all of our videos at any time. Thank you for watching, and we hope to see you again very soon.